So let's just start and let's have happy on learning. And of course, we will do it with understanding. And friends, whenever you find any difficulty, any doubt, so don't be afraid of it. You must ask your queries. You can put your queries in the chat box if you wish, or you can directly talk to me. Rashi, is it possible that these people can talk to me directly?
Yes, sir. Yes, sir.
Okay. But don't keep any doubt in your mind. That is important for us. So we have not much time to discuss different dimensions of regression, but we will do our best to do whatever maximum we can cover in these two sessions, today and tomorrow's sessions. So let's start with some basics. And first, we start with understanding regression. Regression we define as a statistical tool that helps us in doing causal research. And in this, what we have one dependent variable and we have a number of explanatory variables. And we're trying to establish whether there is some relationship between them or not. Dependent variable is normally represented by y. Independent or explanatory variables are represented by x. So what we are looking at whether different independent variables x1, x2, x3, and so on, whether they are having any impact on my dependent variable y, and use of regression analysis, and that will help you in proving or disproving whether we have a relation or we don't have a relationship. Okay, so be clear in your mind what exactly we can do with regression. And if we take simple classical regression module, we have y is equal to alpha plus beta x plus error term. So y is my dependent variable, x is my independent variable, alpha is my intercept, beta is my slope, and this epsilon is called my error term. So what is this intercept? What is this slope? Let's try to understand this. Suppose we have x, we have y. The value of y, if x is 0, that is your intercept alpha. So if you have a regression line like this, the slope of this line, that is your beta. Slope is nothing but change in y with respect to change in x, that's equal to beta. And this is your error term, which behaves in a random manner, and it does not have any systematic pattern. It is totally unsystematic, behaving in a very random fashion. Nobody can predict what will be the value of the error term, but we need it because error term takes care of what is called other things remaining cost or whatever terminology we are using in our model. Alpha intercept, beta slope, and this epsilon, the error term, the E is your error term. And error term takes care of what is not included in the model, that will sit in the error term. And error term has all those variables impact which is not significant, and very small contribution is there for a large number of variables. So
Sir,
error
can you
terms
please
take
give
care.
me one example of error terms? Any example of error terms, sir?
Okay, let me take simple example. Law of demand said demand is a function of price, right? So I say demand is equal to alpha plus beta price. What if the price of the substitutes have changed? Hmm? If the price of the substitute have changed, what will happen? Income
Yes.
changes. What happens?
Income demand
They-
increase in case of price also
But
increase.
that is not in our model, no? So they will sit where? In the error term.
Okay, 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 sir. Got it.
And we assume whenever we work with something, we assume that other things are constant. Income is constant, price of substitutes are constant, taste and preferences are constant.
Prefer-
Okay.
Yes, yes.
So, but actually in real life, they are not constant. So they will sit in
Sir,
my error term.
okay. Thank you, sir.
Okay. Let me take an example from the finance. Rashi, what is the topic on which you are working?
Good evening,
On
sir.
behavioral
Good
finance, sir.
evening.
So I'm working on digital payments,
Okay.
uh, mobile payment apps,
Right.
basically. Anji.
Yes, Prachi, bolo.
Hello.
Yes, Prachi?
Ha, Prachi, please.
So my voice is audible to you?
Yes, yes, I'm able
Yes,
to
yes,
hear
you
you.
are audible.
Sir, my topic of PhD is on digital payments. Basically,
Right.
I'm working on mobile payment apps.
Okay.
Yes, sir.
Right. So, what do you think? Do you think the mobile payment has something to do with the background of the person?
Background of the person?
Right. Like whether he is from rural background,
Yeah.
semi-urban background.
Yes, sir.
So, I can say that the usage of mobile payment is a function of the person of background, right? Can I say that?
Yes, sir.
But besides background, there may be other factors.
Yes, sir.
So if I make a model usage U is alpha plus beta background plus error term will take care of other variables which I have not included in our model, like gender, for example,
Yes, yes.
income, for example, education level, for example. So where they will go? They will sit in the error term. So you may not get the exact relationship between the background of a person and the usage. That relationship will be somewhat different from the real life because of other factors. So this is your estimated thing. Actual maybe this one, and the difference is your error. Actual maybe this one, but your model says this. So difference will be your error term. How the error term will behave, I don't know. It may be positive, it may be negative, it may be zero. We have no idea, no clue about the behavior of the error term, and therefore we say it is random. Stochastic means probabilistic. Prachi, that clear?
Yes, sir.
Okay. So let's see what assumptions we make for this model. We are assuming that on an average, the error term is going to be zero. sometimes positive, sometimes negative, sometimes zero. But on the whole, overall, error term is going to be zero. That's our assumption. We are assuming that the variance of the error term is constant. It doesn't change. If you take 100 people, 200 people, 600 people, 1000 people, you calculate the variances of them. So we are assuming that the variances across will be same. It will not be different. Okay. We are assuming that there is no correlation between the error terms. They are having no autocorrelation or serial correlation. We are assuming that x and the error term both are not correlated with each other. They are independent of each other and their correlation is equal to zero. We are assuming that error term follows normal probability distribution. Now, in this regard, I think let me make one clarification. We have x, we have y, you have error term. Should x and y be normally distributed? Anyone? Should we check normality of x and y? The answer is no. Assumption is only about the error term. Error term should behave normally. X follows normal distribution, doesn't follow normal distribution. I don't care. What is my concern is that error term should follow normal probability distribution. That's the assumption, and that assumption must be satisfied. And we are assuming that x's are non-stochastic, they are given, and they are constant. They don't have any probability distribution. Any question about assumptions? Any doubt about assumptions?
No, sir, thank you.
Okay. Now the question is, if you have made a module, you made necessary assumption, what is the biggest challenge? The biggest challenge is how to get the estimates of alpha and beta. And these are the parameters, and we want to find out the estimates of these parameters. And for that, we use some estimators. And there are two estimators which we use, maximum likelihood method and ordinary least square method, which is called OLS. Or many times this is simply called least square method. Who's the square we are talking about? Which should be minimum? We are saying that we are minimizing the square. Whose square we are minimizing? This is x, this is y. This is your regression equation, fitted line. And these are my actual points. Some of them may be online, some of them may not be online. Difference between the fitted line and the regression line, that's called your error term. So we minimize summation of square of error terms. And then we try to get the value of alpha and beta. Okay? And we take a square because if you take addition, some positive, negative, it will become zero, will not have any meaningful sense. But it will have meaningful sense only when you take a square of it and then you minimize it. Okay?
May I have your attention, please?
Right. So let's see. How do we see the difference between the estimation, estimator, and estimate? because that difference should be clear in our mind. We must know what exactly they are. Estimation is a process of getting estimate. I'm looking for an estimate of my alpha. I'm looking an estimate for my beta. And the process of getting that estimate of alpha and beta is called estimation. Now the question is, what is an estimator? That is something which is important for us. So you have estimation, based on some estimator, and that is giving us anyone. What is an estimator? What is an estimator? Think. What is an estimator? Estimation is the process by which sample data are used to indicate the value of unknown parameter of a population. An estimator is a rule or a formula or an algorithm for calculating an estimate of a parameter based on sample data. And the actual value of the estimate which we get, that is called estimate. So be clear in your mind what is an estimator. Suppose I want to estimate population mean. How do we do it? How can we find the population mean? How we can estimate the population mean? Anyone? Of course, you need sample, right? So you will take sample, and then what you will do? Preeti, Rashi, Lucky.
Sir,
maybe
on the basis of sampling, we are saying कि in our this, for example, if I'm taking equity investor, so on my sampling, I'm saying कि this is the behavior of equity. The whole population, I'm related with that after
तो
that.
फिर पॉपुलेशन का मीन निकालना हो तो कैसे निकालोगे? सैंपल का मीन लोगे ना?
Yes, sir.
ये जो सैंपल का मीन है, we will call it is an estimator of population mean.
Yes, sir.
ठीक है? अगर पॉपुलेशन का वेरिएंस निकालना है तो क्या करोगे?
सैंपल का वेरिएंस निकालेंगे सर.
सैंपल का डेटा लिया, क्या फॉर्मूला यूज करेंगे?
अंडर रूट सिग्मा एफ डी स्क्वायर.
वेरिएंस की बात कर रहा हूँ.
वेरिएंस, ओके.
x माइनस
एक्स बार मीन वैल्यू जो है सर, इसका स्क्वायर. जी.
समेशन ऑफ इट
यस सर.
डिवाइडेड बाय
2 नहीं, सिग्मा एक्स माइनस एन माइनस 1. ओके.
तो ये सैंपल वेरिएंस का एस्टिमेटर कहलाएगा. ये जो फॉर्मूला हम यूज कर रहे हैं, दिस इज कॉल्ड एस्टिमेटर ऑफ पॉपुलेशन वेरिएंस.
बट सर इसमें जो सिग्मा एक्स माइनस एक्स बार का होल स्क्वायर डिवाइडेड बाय एन माइनस 1,
हाँ,
इट इज डिफरेंट फॉर ऑड नंबर ऑफ सीरीज और इवन नंबर ऑफ
नहीं,
सीरीज.
इसमें कोई फर्क नहीं पड़ेगा.
ओके सर. ठीक है सर.
ऑड इवन तो हम तब कैलकुलेट करते हैं जब हम मीडियन कैलकुलेट करते हैं.
ओके सर।
हमें
जी।
मिडिल पॉइंट चाहिए होता है ना उसमें,
हम्म।
तो वहाँ
जी
ऑड
सर,
इवन का चक्कर होता है,
यहाँ पे नहीं है, ठीक है
वेरिएंस
सर।
में नहीं होता।
जी सर।
ठीक है, मैं इसलिए इस चीज पे एम्फेसाइज कर रहा हूँ क्योंकि रिग्रेशन एनालिसिस में हमारे पास जब भी हम एडवांस जाएंगे तो हमें बहुत सारे एस्टिमेटर मिलेंगे. OLS is one, GLS is another. GLS stands for generalized least square, WLS weighted least square, maximum likelihood, generalized moments method. There are so many estimator which will come across. तो तुम्हें अपने माइंड में क्लैरिटी होनी चाहिए कि तुम कर क्या रहे हो, किस चीज पे आप फोकस कर रहे हो, क्या आपका एस्टिमेटर है, वो पता होना चाहिए हमें. अभी हम जो जिस एस्टिमेटर की बात कर रहे हैं वो है OLS, ऑर्डिनरी लीस्ट स्क्वायर मेथड. So OLS is the estimator, and these actual values which we get, they are the estimates, and the process of getting the estimates is called my estimation. That's how we see the difference between estimator, estimate, and estimation. Okay. Another thing which you have to be very clear about our OLS estimator is what are the properties of the OLS estimator. We say OLS estimator is a blue estimator. Why it is called blue? Because it is best as it has the minimum variance. It's a linear. It's unbiased, and it is estimator. And that's the reason it is called blue estimator. Best, linear, unbiased estimator. So what is all this? Let's try to put some time in understanding these properties. It's a linear because you see we are dealing with the linear functions. So the estimates also become linear of my variables. So we are not dealing with any non-linear functions. We are not dealing with any non-linear estimator. We are dealing with the linear estimators. Okay, that's the reason my OLS estimator is linear estimator, unbiased. What is an unbiased estimator? Yogesh, Renu, Lucky, Prachi, who else?
Sir, unbiased means it don't give preference to any of the component which is there for the estimation purpose. Like when we use the sample mean, it is not giving preference to any of the sample value.
Okay. Renu, you must make a difference between unbiased and random sampling.
Okay,
When we
sir.
talk about random sampling, we are not giving any weight to anyone. All are equally likely. All are, have equal chances of being selected. But that is not unbiased. That is not unbiased. What is unbiased? We have to think. What is unbiased? Anybody else? Just give me a minute.
Sir, maybe the value which we estimate represents the population.
Yes. Now you are right.
Okay, thank you so much.
Suppose population estimator is theta, right? And sample is theta head. And friends, please understand this symbol head. Whenever you are reading any article or reading any text and you see this symbol on a particular variable, in that case, it is considered to be an estimate. Okay. If the mean of the estimate or the expected value of the estimate equal to the population parameter, then we say it is unbiased. That means what? You go on taking samples, one sample, two, three, four, five, and if you take the average of those, if that is equal to the population parameter, then we say it is unbiased estimator. Okay? Now, what is efficient estimator? An estimator is said to be efficient if it has minimum variance. And if you remember, variance is indicator of standard errors. So an estimator is said to be efficient if it has minimum standard error or it has the minimum variance. Consistent is a large sample property. As sample size increases to infinity, if my theta head converges to population parameter, then it is called consistent. And sufficient means it is based on all available information. That means my estimator is making use of all available information, not ignoring any information. So, for example, when I calculate median, some information I may not consider. When I calculate mode, some information I may not be considering. But when I calculate mean, I have to take all available information. So I will say my mean is a sufficient estimator. Friends, any question about these properties? Because of these properties, OLS estimators are called best estimators. Friend, don't hesitate. If you have any question, any doubt, please. If you don't want to talk to me directly, you can put your queries in the chat box.
Sir, the concept is clear till now.
Okay. Please remember, we get the estimates of the parameters of the model using sample data, and therefore they have their own sampling distribution. Now the question is, what are the properties of the sampling distribution of alpha? What are the sampling distribution properties of the beta? So that is the next thing which we are going to talk about. And you will find that alpha beta are also following normal probability distribution. Unbiased estimator, so their mean is equal to the population parameter, and this is their variances. And if you take the square root of them, that will be called standard error. So friends, alpha betas are following the normal probability distribution with the mean equal to the population parameter and with the standard error which is given here. Right? Y error term is following error normal distribution, so Y will also follow normal probability distribution. With mean this and with the variance this. Divided by n minus. Error term also follows normal probability distribution with our assumption. Its mean is 0 and its variance is variance of summation of the error square. That's what we get. So now let's be clear what we have done or what we have learned so far. We said this is our regression model. Error term follows random behavior, and we make certain assumptions about the model. And to get an estimate of alpha and beta, we are using OLS. And whatever estimates we get, they are the best estimates. They have what is called blue property. OLS estimates are consistent, efficient, sufficient, linear, unbiased. And then we saw that alpha, beta, y, error term, all these numbers which we have here, they follow normal probability distribution. Okay. Any question up to this point? Any doubt?
No, sir. Thank you.
Okay. So let's see how we can use it. I don't know. Have you people downloaded Cradle?
Yes, sir.
Okay. I've shared the data also.
Yes, sir.
If you're able to open it up, you can open this with me. It's taking some time. Are you able to open it up? Let's go to file. I think I have to open it again. There's some problems. I have to open it again. So go to file, open data, user file. So wherever you have file, you can open it. And at the bottom, you will see Gretel data files. If you click here, you can click on Excel. And you will to open up. Let's work with the very first file, BP and BP and weight problem. Start to import from one row, one column. Okay. Check. I think there is some problem with this file. There's some problem in this file. So let's open the other file. Suppose I take Wipro and data file P and beta. Do you want to give the data and time series or parallel interpretation? You say no. Let me change my. I'm changing my working directory. Just give me a minute. I just changed my directory here.
No issue, sir.
Okay. Friends, are you able to open up this file? P and beta? What we're trying to say is that there is a relationship between the risk of a company and price earning ratio of that particular company. So beta is the measure of risk, and price earning ratio is a measure of the profitability of the company or behavior, how the share is doing in the market. Okay, so what we are going to do here, First, we have to make a graph of it. Sorry, if you want to see the data, you select both of them, right click, display values. You will see the data which you have. This is the data we have with us. Okay. I want to make a graph. Which graph I should make to see the relation between them? Yogesh, Lucky, which graph I should make to see the relationship? View, graph. Which graph I should make?
Hmm.
A scatter plot.
It's good.
Beta is my
So,
x-axis,
okay.
P is my y, and then you say okay. That's the graph which we get. This shows there is a negative relationship between the beta and the p ratio. Higher the risk, lower the p ratio. So you can make a graph also, right?
Yes, sir.
Then I have to estimate the model. So go to model, OLS, y is my dependent variable is PE, and regressors or independent variable is beta, and then you say okay. And that's the result which we get. Let me increase the font size. Okay, now the question is what this output represents. So let me select this output. And I'm just putting it here. Uh, so this is the model which we get. So let me explain what is the output which we get here. My dependent variable is P ratio. So PE is equal to constant 60.5840 minus 12.4326 beta. This is my estimated model which I get. This negative sign shows that higher beta means lower P ratio. So if the risk is high, my P ratio will be low. If the risk is low, my P ratio will be high. That's what it means. Okay. Another thing, look at the P values and this star. Star means this is significant. That means beta is significantly different from 0. Alpha is significantly different from 0. So what is the null hypothesis we are testing here? Null hypothesis is alpha is equal to 0. Alternatively, alpha is not equal to 0. P value is less than 1%. Therefore, my null is rejected. I can say my alternative hypothesis is true. That means my alpha is greater than 0. In case of beta, what we have is following. Null hypothesis is beta is equal to 0. Alternatively, beta is not equal to 0. Less than 1, so null is rejected. Alternative is accepted. So friends, understand couple of things here. First, sign of the beta shows the relationship direction, whether you have a positive relation or you have a negative relation. P value and the t statistics help us in getting my hypothesis testing for alpha and for the beta. In both the cases, we assume that values are equal to 0. Whatever software you are going to use, whether you are using Excel, Gretel, eViews, Stata, or whatever software you are using, all softwares have a null hypothesis. Alpha is equal to 0, beta is equal to 0. Alternatively, they are not equal to 0. Gretel puts up stars, triple star, double star, and single star. Triple star means it is significant at 1% level. Double star means significant at 5% level. Single star means significant at 10% level. Okay, and you know how many observations my model is using? 2745. Any question up to this point? We proceed further otherwise.
No, sir.
This is the mean of the dependent variable, that is mean of the P ratio. So in our data, P ratio average is 32.90455. This is the standard deviation of the dependent variable. And this is the sum of squared residuals. And this is the sum of the standard errors of the regression. So this is nothing but the standard deviation of error. Value of the R square is this much. 10.57% is my R square. Okay. Any question about this output which you have in your mind? Any questions if you have in your mind? Any number which you think you are not able to understand? Adjusted R square we will discuss later on. Anything which you think that you must get clarity about it? No? Okay. So just we close it. Let me open another file. Open data, user file, simple regression. Suppose I take Wipro and Sensex file. Select them, right click, display values. These are the values which we have. Rashi, how do I estimate the beta of Wipro? Anybody else? I hope you must be knowing what is beta of a company. How do you estimate beta of a company? अरे तुम लोग बोलो ना बीटा कैसे एस्टिमेट होता है? यस निकिता.
Sorry, sir, haven't any idea.
Okay. Rashi, who is from finance? Who is from finance? Okay. I don't take this. Let me take some other. Let me take some other file. There's a folder multiple regression. In that we have a file BP weight, BPWT problem XLS. And I want to establish the relationship between BP and weight. So first, what I do is I make a graph. So view, graph, scatter plot, dependent is weight, and Y is my BP. I say okay. That's the relation which we get. So you can quickly make a scatter plot with the regression line fit into it. Then if you want to estimate the regression line, go to model, ordinary least square, OLS. Dependent variable is BP. Weight is my independent variable. And that's the result which we get. 3 star, that means weight having a significant impact on the blood pressure. R square is 45%. That means 45% of the variation explained by the model. Friends, I'm not in a hurry. Make sure that you understand the output. If you have any doubt about the output, let me know. Any question about output? No? So I hope you must be able to do el- elementary or the beginning or the initial task with the crater. You can make a graph, you can run the regression model, you can see the values, all those things you can do very comfortably with this open source software Cradle. So friends, so far so good. And any questions if you have, any doubt, any query if you have? No? So we will take a 2 minutes break, and after 2 minutes break, we will continue, and 5 minute break, 2 minutes break, we will come back again. Rashi, 2 minutes break will be okay?
Yes, sir.
Okay. So after 5 minutes, we'll come back. Should we start?
Yes, sir.
Yes, sir.
So let's start. Any questions if you have before we proceed further? Any doubt? Any query?
No, sir.
Okay. So let's see what next we are going to talk about is we have to move ahead, don't stop, keep learning. That's our journey of learning. So now let's move towards multiple regression. Instead of one independent variable, we are going to have multiple independent variables. In our earlier model, we have one x impacting y. Now we have multiple x impacting y. This is called simple regression model. This is called multiple regression model. What about the assumptions? We have the same assumptions as we have for the simple model. Mean of the error term is 0. Variance of the error term is constant. Error terms are not correlated with each other. X is not correlated with error term. Error term for a normal probability distribution. The only difference in this multiple regression model regarding assumption is x's are not linear functions of other explanatory variables. That means x's are independent. That the only addition we have in this multiple regression model. Otherwise, all assumptions are same as we have for the simple regression model. And estimation method is same. OLS we use. So let's take some exercise and see how do we do it in Gradle. So we have already two variables here, age and weight, and it's a case of multiple regression model. Go to model, ordinary least square. Dependent is my BP. Age, weight are my regressors. Then you say OK. And that's the regression result which we get. So weight is significant. Age is also significant. Weight is significant at 5% level and age is significant at 1% level. And that's what we get. Any questions here? Let me see if we can copy it.
Sir, could you please tell us again that what is double star and triple star meaning?
Okay. Just let me just copy this. Single star means significant at 10% level. Double star means significant at 5% level. Triple star means significant at 1% level. So, Prachi, that's what it means. My estimated
Okay, so
equation is BP is equal to minus 28.046 plus 0.489 weight plus 2.16 H. That's my estimated model. R square is 68.99%. R square represents variation explained in dependent variable. So my dependent variable is blood pressure, and my independent variables are weight and age. Weight and age both together explain about 69% variation in BP. 31% variation in BP is still unexplained, maybe because of other factors. Okay, any question here? Anything else? Nishant says no. Okay, good. Right, so let's go ahead. And how do we interpret the results? What does it mean? Dependent variable is salary. So change in salary with respect to rating is 1.0577. What does it mean? If my rating increases by 1 unit, my salary will increase by 1.0577. Keeping experience constant, keeping certification constant. So the change in salary with respect to change in certification is 1.0577. 0.299. That means if my certification increases by 1 unit, 1 point, salary will increase by 1.29 if I presume that my rating is constant and my experience is constant. Okay? I hope you understand what exactly we are talking about. Many times we take log of variables. So when you take log of variables, what does it mean? Suppose I take log of y alpha plus beta x plus error term. What is the interpretation of beta? If you take log y here, anyone? Whenever you take log, this is interpreted as percentage change. So in this case, what does it mean? If x is increasing by 1 unit, beta will be the percentage change in y. That's how we interpret this. And if we take a log of x as well as log of y, then this will mean percentage change in y with respect to percentage change in x, that equal to beta. Let me take, there is one more file. I just open another file. Multiple regression. There is a file with the name of salary data, right? So I open it up. My model is ordinary salary dependent, and this is okay. So that's the result which I get. Suppose I calculate with log, what will happen? So first I have to define a log variable. So add logs of selected variables. Suppose I select salary, add log of salary, L salary, and one log of salary. So now my model will be log of salary If you compare these two results, you will find these two results are different because I have taken log of y, log of salary. So in that case, interpretation of the coefficient in case of a log will be 1 unit change in experience, for example, will lead to 0.0059 percentage change in salary. So that person's salary will increase by 0.005%. That's how we understand this. Any question here? Any doubt? Any query for any one of you have?
सर
Yes. Yes,
सर
Prachi.
मेरी क्वेरी है
हाँ,
जो
बोलो.
आपने इंटरप्रिटेशंस में पी वैल्यू बताई थी 2 पॉइंट लाइक 10 ई समथिंग ऐसा कुछ राउंड ऑफ था सर मुझे ये पूछना था कि ऐसा भी वैल्यूज आती हैं पी वैल्यू की मतलब ई में भी क्योंकि मुझे तो देखा है कि लेस देन 0.00 या ग्रेटर देन ऐसा कुछ
ग्रेटर देन 0 आती है. ग्रेटर देन क्या?
सो जैसे लेस देन या ग्रेटर देन 0.05 तो पी वैल्यूज हम पता है कि होती हैं जैसे
हाँ.
इंटरप्रिटेशन में 3.10 ई माइनस
अच्छा.
लाइक हैश 100 समथिंग
ठीक
था
है, ठीक है, ठीक
तो
है.
वैसा भी आती
जैसे
है
यहाँ पे है ना 2.64 e माइनस 013, राइट? ये ना,
यस
इसका
यस
क्या मतलब है?
तो ऐसी वैल्यूज भी आती हैं जब हम करते
हाँ,
हैं
हाँ,
इंटरप्रिटेशंस या
ठीक है. सो माइनस 10 e टू द पावर माइनस 13 और प्लस 10 e टू द पावर माइनस 13, राइट? इसका क्या मतलब है? इसका मतलब है 10 इंटू 10 टू द पावर माइनस 13. तो ये किसके बराबर हो गया? 10 divided by 10 to the power 13, which is almost 0. ये देख रहे हो ये वैल्यू?
हाँ जी
तो ये क्या है? 3.66 into 10 raised to the power minus 22, which is approximately equal to 0. तो ये जो है वो इसकी सेंस में आएगा. ठीक है? ठीक है प्राची?
so so we can also simply write it like p is less than 0.01
We can,
okay
because
okay
this is
actually sir this
less than
problem is same come with me
0.001. This is less than 0.001. This is less
okay
than
okay
0.001.
okay
This is, that's why it has all the 3 stars, right?
yes so
So that means they are significant at 1% level. P value is less than 1%.
yes so okay so thank you
Okay. So what next we are going to talk about is can I increase the value of R square by adding more and more variables into our model to get a better model? We have one variable in Y. We have two variables. We have three variables. What will happen to the value of R? Let's call it R1, R square 1, R square 2, R square 3. What will happen to the values of R square? Will it go on increasing or reducing?
increases
Yes. So whenever you add any variable into your model, the value of R square will always be higher. But it could be possible that, that variable which you are adding contributes very insignificantly. But it kills what is called degrees of freedom. जैसे जैसे आप पैरामीटर्स बढ़ाते जाएंगे, वेरिएबल्स बढ़ाते जाएंगे, आपकी डिग्रीज ऑफ फ्रीडम कम होती जाएगी. तो एक जगह तो आपको आर स्क्वायर बढ़ता नजर आ रहा है, दूसरी तरफ डिग्रीज ऑफ फ्रीडम आप लूज करते जा रहे हो. तो हाउ टू कीप ए बैलेंस बिटवीन दीज टू? मतलब कंट्रीब्यूशन इनसिग्निफिकेंट है और जो डिग्रीज ऑफ फ्रीडम है वो मैं ज़्यादा लूज कर रहा हूँ, ये तो कोई सेंस नहीं बनती ना. How do I know that the gain in R square I'm getting is more than the loss which I am having due to the degrees of freedom? You understand my question? In that
Yes,
case,
sir.
what we do, we calculate what is called adjusted R square. So adjusted R square is nothing but R square, which is adjusted for degrees of freedom. So R square will always be increasing, but adjusted R square may not be always increasing. So in that case, if you have to compare two models, y with two variables, y with three variables, y with four variables, to decide which model is a good model, we make use of adjusted R square. So when we are working with multiple regression model, simple model, we work with R square because there is only one variable, no question of any loss of degrees of freedom. When you have multiple regression, and we have k variables, and you have to decide which model should be selected for that we use adjusted R square. So I repeat, we use adjusted R square to decide which multiple regression model is good for us. That's it, nothing else. And what is the interpretation of R square? R square is variation explained divided by total variation. That means percentage of variation explained. That is the interpretation of R square. So I hope you get a clarity between these two. And that's the way we calculate adjusted R square. And these are nothing but my degrees of freedom. Adjusted R square can negative be also. Like here, we have negative adjusted R square. So if your model is giving you negative adjusted R square, that model is not acceptable. There may be a number of reasons behind getting negative adjusted R square. One, model may not be properly specified. Two, you may have added too many variables in your model. Third, the number of data points is very less. Because of these reasons, it might be possible that adjusted R square is negative. And friends, never work with negative adjusted R square. Do something or the other so that it becomes positive. What else about variation explained? R square or adjusted R square? Quick. Prachi, Renu, Rashi, Rishabh, sorry, Lucky,
Art
Nishant.
scare.
Huh? Hello? Prachi, I'm not able to hear you what you said. R square. Just
Could you
Nisha,
please?
R square. R square tells us what
Yes,
is
sir.
the proportion of the variation explained. Okay, now let's move to our next challenge in understanding regression. How does a researcher know whether his or her regression model is a good model? How do we know? I've developed a model, I'm feeling very happy, but other person say it's all bakwas, बेकार है, कुछ नहीं है. How do we know it? कैसे पता लगेगा कि मेरा जो मॉडल है वो एक अच्छा मॉडल है? How do I know? How can I convince the others that look, whatever I've done is good? It makes a sense. How do we know it? So for that we have criteria. The most important criteria is theory. Whatever model you are making should get a support from theory. So when I say theory, that means I am referring to it should get a support from the theory or from the literature. You must have a reason why I'm making this particular model. You must have a reason for it. ऐसा नहीं कि हम हवा में मॉडल बना रहे हैं, नहीं. We have a solid reason behind it. We must know why we are making a particular model. Theoretically, through literature, we are able to justify that. Okay. Second, which is called the statistical criteria. Looking at the indicators of goodness of fit, and the indicators are support from the literature, that's there, and we look for adjusted R square, the standard error of regression, that means standard deviation of error term. Okay, higher adjusted R square, that means model is good. Lower the standard error of the regression or lower the standard deviation of the error term, model is good. Then we also have what is called information based criteria, and they are based on the concept of loss of information. तो जितना कम लॉस होगा उतना मेरा मॉडल अच्छा होगा. तो जो भी we call it in short AIC, BIC, HQIC, information based criteria, ये जितने कम होंगे my model will be good model. And please remember, you may get these numbers negative. That's model 1. That's model 2. किसका कौन सा मॉडल अच्छा होगा, मॉडल 1 और मॉडल 2? अगर AIC इंफॉर्मेशन ऐसी है तो निशांत कौन सा मॉडल अच्छा होगा, 2 1? किसका AIC कम है, 1 का 2 का?
1 का सर.
Nishant, you are right, it is 2. Minus 27 is lower than minus 26. So this is good, this is not good. Why I'm saying so? Because many times I've seen that students are committing a mistake. They get confused between the negative number and a positive number. Higher the negative number, that means it's a lower value. Says Nishant, you're right. Second will be the right answer. And then we can have overall testing of the model, F test, and we can also look for individual significance of the variables by looking at the t test. So these are some of the statistical criteria which we use to test the goodness of the fit of the model. Okay. Third, which is important for us, is econometric criteria. The assumptions which you are making, how valid those assumptions are. We have to check the assumptions. Your model is good as long as your assumptions are true. If your assumptions are not true, your model is not a good model. I can't use OLS because my assumptions are not true. Okay, so that violation of his assumptions which we have, and first assumption is error term does not have a zero mean. If you remember, we said that error term should have a zero mean. What if it doesn't? क्या होगा अगर error term का mean zero ना हो तो? How you will get it? It means that expected value of the error term is not zero, and if a constant term is included in the regression model, then this assumption will be never violated and we should not worry about it. But if you do not have a error intercept a term or the alpha term in the module and the error term is mean is not equal to zero, then you will be in trouble. Your estimates will be bias estimates. So the conclusion is always use intercept in your model. Always do that. If you don't do it, there is a possibility that you may have unbiased, you may get biased estimates. I show you what I mean by this. This is our salary problem, and we have this, and we have a constant here. Now let me run a model where we don't have a constant. Modify model. I throw a constant out. Now, do you see the average performance is coming to be 3.61969, 325 certification 4 times. Standard error is increased like anything. If you see here, standard error of regression 1.72 and in the scale 6.58. So this model is not a good model. If you save the error term here, save residuals. Okay, so I type resid. And if I calculate the mean of the summary statistics of the resid. Sorry. Do you see mean is not coming to be 0, 1.07? And because of this, there is a problem in it. And when you have the intercept, and I save the residuals of this module. Let's call it resid 1. If I calculate the summary statistics of it, instead it is coming to be 0. So lesson is that whenever you are working with your model, always have intercept. If you have that, this assumption will never be violated and you should not worry about it. Okay, now let's move to the second assumption. Second assumption is that error term follows normal probability distribution, and violation of it will mean error term does not follow normal probability distribution. Do not follow normal probability distribution. अगर मेरी एरर टर्म नॉर्मल डिस्ट्रीब्यूशन फॉलो नहीं करती है तो क्या होगा? सोच सकते हो क्या इम्पैक्ट होगा? If error term does not follow normal distribution, तो क्या होगा? What will happen? Think. What will happen? क्या हो सकता है? What will happen in that particular case? I will not be able to make use of T statistics, F statistics, chi-square, which are based on the assumption that the underlying distribution is a normal distribution. So all hypothesis testing cannot be done if the error term is not following normal probability distribution. But interesting thing is my estimate will still be blue. So the consequence is estimates are still blue, but we can't use t-test, we can't use f-test, we can't use chi-square test. All those tests cannot be used, and if I cannot use them, then my hypothesis testing results will be, you know, what to do. क्या करें? अगर मेरा डिस्ट्रीब्यूशन नॉर्मल नहीं है तो क्या करें? Two things we have to do. First, check. Second, correct the problem. कैसे पता लगाएं कि मेरा जो एरर टर्म का डिस्ट्रीब्यूशन है वो नॉर्मल नहीं है? अमन, कैन यू ट्राई? कैसे टेस्ट करते हैं कि डिस्ट्रीब्यूशन नॉर्मल है कि नहीं? कैसे पता लगता है? एनीवन? निशांत, अमन, रेनू, प्राची, राशि? हाउ डू वी नो कि डिस्ट्रीब्यूशन नॉर्मल है कि नहीं?
Sir, mean, median, mode value should be equal.
क्या चीज?
Sir, mean, median, mode value we calculate and it is equal.
That means you will look at what is called basic statistics, right?
Yes, sir.
Basic statistics में स्क्यूनेस क्या होनी चाहिए? 0.
Zero, sir.
कर्टसिस क्या होनी चाहिए?
मेसोकार्टिक
3.
3 सर.
जी सर. जी सर.
ठीक है. दूसरा क्या तरीका हो सकता है? ग्राफ.
Yes, sir.
कौन सा ग्राफ?
हिस्टोग्राम.
और थर्ड, statistical test. These are the three ways. These two are suggestive. सजेस्ट करते हैं, कंक्लूड नहीं करते हैं. जो टेस्ट है वो कंक्लूसिव है. आप ये बना लीजिए, ये कर लीजिए, पर अल्टीमेटली आपको टेस्ट तो करना ही पड़ेगा. इफ यू कांट डू द टेस्टिंग देन यू कैन नॉट प्रूव कि डिस्ट्रीब्यूशन नॉर्मल है कि नहीं. You can have basic statistics, you can have QQ plot, histogram, KS test, and Jerick-Berer test. This is non-parametric, less powerful, so we prefer not to use it. We prefer to use Jerick-Berer test, which is a parametric test, which is more powerful as compared to KS test, the Kolmogorov-Simonov test. Okay, so coming back to our, if you remember, we save the residuals. I can make a histogram of it. View, specify graph. You can make QQ plot, residual 1. So if all dots are not on the line, that shows the distribution is not a normal distribution. We can make a histogram also. Tests normality of residuals. If you see the graph, what you get looks to be normal, but slightly more peak somewhere, but that may be random. Do you see this? Test for null hypothesis of normal distribution. तो null hypothesis क्या है कि distribution normal है. और p वैल्यू 0.94, तो नल हाइपोथेसिस रिजेक्ट नहीं हुए है, इसका मतलब डिस्ट्रीब्यूशन नॉर्मल है. Let me take one more quick answer. I just open another file. Suppose I take quantity of T. My model is quantity of tea depends upon price of coffee and price of tea. And that's the result which we get. Price of coffee and price of tea are coming to be significant at 1% level. Sorry, price of coffee is coming to be significant at 1% level. Price of tea is coming significant at a 5% level. Okay, I want to check normality. So go to tests, normality of residual. Do you see the peak here? You have a lot of peak here. And this shows a skewed function. Let me see if I get something here. I don't know whether I... Anyway, do you understand this output? So if you see here, high peak, skewness. So this indicates that the distribution may not be normal. For that, we use the normality test, and normality test says this is 0, and as it is as a 0, if I just copy this, that means null hypothesis is rejected. Therefore, the distribution is not a normal distribution. So we have checked that distribution is not normal. So what to do if it is not normal? What should we do if it is not normal? If it is not normal, then if your sample size is large, because the central limit theorem, we will say that our underlying distribution is a normal distribution. And if you're concerned with the point estimation, then it's not a problem. You can go without normality testing, because normality is for hyper testing and nothing else. Sample size is small, then it might be possible that the skewness is because of some extreme values. If you delete those extreme values or outliers from your model, it may become a normal distribution. Or you can do some kind of a transformation, like you can take a log and the distribution may become a normal distribution. So you can make a distribution normal by doing some adjustments. If it is large sample, 500, 600, 1000, you need not worry. Forget about normality. If it is a small sample, then you have to worry about it and identify if there is any outlier, remove it, and your distribution will become normal. So variance of error term is not constant. That we will take tomorrow. If you have any questions, any discussion, you let me know. Otherwise,
Thank you so much, sir. Any doubts, any question, please ask.
so thank you very much.
Thank you, sir. Thank you.
So tomorrow we will finish the other violations, and after that we will start with the time series. Okay, stationarity and non-stationarity, all those things we will discuss tomorrow.
Okay, sir.
Okay,
Thank you, sir.
thank you.
थैंक यू
sir.
सर, आपने बहुत ही सिस्टमैटिक और बहुत ही एग्जॉस्टिव आपने रिसर्च स्कॉलर को समझाया. थैंक यू
पता नहीं
सर.
उनको कितना समझ में आया.
हाँ वो तो है, लेकिन फिर भी, और इतना जल्दी भी समझ में नहीं आएगा सर, लेकिन थोड़ा प्रैक्टिस करेगा बच्चा तो कर लेगा.
हाँ हाँ.
तो
और ग्रेटल बहुत सिंपल सॉफ्टवेयर है और बहुत आराम से कर सकते हैं.
मैंने भेजा है सबको ग्रुप में कि आप लोग इसको डाउनलोड करो, और फिर आपने जो डेटा के लिए भेजा था वो भी मैंने ग्रुप शेयर किया है.
हाँ वो किया है.
Sir, in this software, it is possible कि we get an interpretation or analysis in numerical. मतलब they are giving the values. Is it possible for us to take the analysis also, because it help in writing thesis
राशि,
when we are writing? Yes, sir.
तुम ऐसा सॉफ्टवेयर ढूंढो ना तुम्हारी थीसिस ही लिख दे. अरे तुम भी तो कुछ अपना दिमाग लगाओ.
नहीं sir, actually scholars are asking for this. That's why I'm asking on behalf of scholars.
नहीं.
हमने लिख दी है sir thesis.
इंटरप्रिटेशन जो होता है बहुत सब्जेक्टिव होता है.
Okay.
आप क्या देख रहे हो उसमें, ठीक है, आपको क्या नजर आ रहा है, हर एक को तो वो चीज नजर नहीं आएगी ना. सिग्निफिकेंट है कि नहीं वो तो आपको दिख ही रहा है. उसके लिए इंटरप्रिटेशन क्या है, उसका क्या इम्पैक्ट होगा, आपके ऑब्जेक्टिव के साथ कैसे मैच कर रहा है, नहीं कर रहा है, वो तो आप ही देख के बताओगे ना.
जी सर. थैंक यू सो मच सर.
चलो ओके. सो कल मिलते हैं फिर. ठीक है
सर. थैंक यू सर.
ओके बाय बाय.
बहुत ही सबसे पहले
प्राचीन सॉफ्टवेयर का नाम है ग्रेटल.
हाँ ठीक है, वो लिखा है हमने उस पर व्हाट्सएप ग्रुप पर. सबसे पहले थैंकफुल कि सर आपने इसको एक्सेप्ट किया.
अरे माय प्लेजर. आपने बोला तो मना नहीं करता. तो ग्रेटल सॉफ्टवेयर है और आप गूगल करोगे तो डाउनलोड फ्रीली डाउनलोडेबल है. ये कोई दिक्कत नहीं है उसमें. ठीक है.
थैंक यू सो मच सर. बहुत ही बेसिक्स चीजें समझ आई हैं. लाइक थोड़ा सा मैं हेजिटेंट करती थी कि बेसिक चीजें पूछने में कि पीपल जज करेंगे कि बेसिक्स नहीं पता स्टैट्स के.
प्राची तुम्हारा प्रोग्राम है, अगर तुम ही शर्म करोगे तो फिर क्या फायदा है. बेहिचक होके पूछो, खुल के पूछो, कोई दिक्कत नहीं है.
थैंक यू सर. आपने बहुत ही क्लियरली चीजें क्लियर कर रही हैं. थैंक यू सर उसके लिए.
ठीक है, तो कल मिलते हैं फिर.
ठीक सर. थैंक यू
सर. थैंक यू सर.
थैंक यू वेरी मच. हैव ए नाइस डे. हैव ए गुड डे.
बोलो राशि।
ठीक है। हाँ जी सर, सिन्हा सर, आप कुछ कह रहे थे?
नहीं हम लेके थैंक यू। कल भी थोड़ा
आइए।
2 मिनट।
अरे सर, आप प्लीज थैंक यू ना बोला करो, बच्चे हम आपके,
नहीं
ऐसे ना शर्मिंदा करो।
हमने कहा कि तुम कल भी 2 मिनट, कल तो मतलब इंट्रोडक्शन देने की जरूरत नहीं है,
हाँ
बस
जी, हाँ
वही।
जी, करवा दूंगी सर इंट्रो।
हाँ बस
सर मेरी गुड़िया से मिलो सर, आपके
जय श्री। और कितनी बड़ी हो गई?
6।
लेकिन दांत तुम्हारा कहाँ गया?
दांत तो चूहा ले गया।
चूहा ले गया? तो चूहा कैसे आया जो ले गया तुम्हारा दांत?
अब दूसरा दांत आएगा।
हाँ बहुत बढ़िया। किस क्लास में पढ़ती है?
In which class you are?
I am
Actually, she is confused, sir. She is past UKG and now going to first. Nowadays, she is free, no class.
तो अच्छा है, लड़की टैलेंटेड है, इसका चेहरा बता रहा है कि टैलेंटेड लड़की है।
सर को एक श्लोक सुना दो कोई भी संस्कृत का जो दादू से सीखा है।
वक्रतुंड महाकाय सूर्यकोटि समप्रभा निर्विघ्नं कुरु मे देव सर्वकार्येषु सर्वदा। ओम शांति शांति शांति।
वेरी गुड। वो गुरु वाला तो सुना दो सर, तो मेरे गुरु जी है ना।
गुरुर्ब्रह्मा गुरुर्विष्णु गुरुर्देवो महेश्वरा गुरुर्साक्षात् परं ब्रह्म तस्मै श्री गुरुवे नमः।
Very
लास्ट
good.
में गायत्री मंत्र और सुना दो लास्ट में।
ओम भूर्भुवः स्वः तत्सवितुर्वरेण्यं भर्गो देवस्य धीमहि धियो यो न प्रचोदयात्। ओम शांति शांति।
बहुत बढ़िया।
मेरे से ज्यादा अच्छी संस्कृत बोलती है सर।
हाँ, बहुत बढ़िया।
सर के पास भी आप जैसी डॉटर है,
हाँ,
तभी तो सर को बेटियां अच्छी लगती हैं। थैंक यू बोलो सर को। मम्मा को डॉक्टर इन्होंने बनाया, पता है आपको? आप बोलते हो ना मम्मा डॉक्टर राशि मलिक, सर ने ही बनाया है।
कोई नहीं, ये भी डॉक्टर बनेगी।
ना सर ना, खेलन दो।
नहीं, डॉक्टर पढ़ाई का बनेगी, डॉक्टर
नहीं पढ़ाना नहीं सर, ग्रेजुएशन ही बहुत है, इसके आगे नहीं। हम तो अब इतने साल से पढ़ाई नहीं खत्म हो रही सर, किताब ही नहीं छूट रही।
टीचर का किताब कभी नहीं छूटता, टीचर कभी बूढ़ा होता नहीं।
वही मैं कह रही हूँ सर, बुक्स ही नहीं छूट रही। आज से हर सेमेस्टर में सब्जेक्ट चेंज हो जाते हैं सर। पूछो मत सर, पूछो मत। मैडम ठीक है सर?
हाँ मैडम ठीक है, मैडम जुड़ी होगी बीच में।
अच्छा, माता जी ठीक है?
हाँ माता जी ठीक है। माता जी का तो क्या है, बस जो भी हैं जैसे हैं वैसे भी ठीक हैं।
आप अपना ध्यान रखिए सर।
ठीक है, हम भी ठीक हैं।
कल का सर का स्टार्ट करवाना है 6 बजे।
हाँ 6 बजे स्टार्ट।
आज वाला ब्रीफ करके कल वाला स्टार्ट करवा लेंगे।
हाँ स्टार्ट करा देना, कल लास्ट ही है। और कल 5 मिनट लास्ट में मैं एक बार फीडबैक करा देना कि आप लोग को कैसा लगा सेशन, और बाकी ठीक है। बाकी अब बच्चे इंटरेस्टेड नहीं है ना।
एक्चुअली सर क्या होता है, जो शुरू में होता है ना बेसिक, उसमें तो हम कैच कर पाते हैं, फिर वो ज्यादा डिटेल में चला जाता है ना सर। और ये ह्यूमन टेंडेंसी है सर, हम क्लास में फिजिकली भी पढ़ा रहे हो ना तो 50 मिनट के बाद नहीं सुन पाते।
वो ठीक है, लेकिन हमने जो सीक्वेंस लिया था ना, वो इसलिए लिया था लोअर से अपर की ओर गए। हाँ, अब ये तो इकोनॉमेटिक्स पर आ गए। कई बच्चे का डिमांड था कि इकोनॉमेटिक्स कराओ सर। करा दिया।
वो प्राची का था होगा शायद, वो प्राची और रेनू पूछ रहे थे सर।
हाँ, और दूसरा ये है कि प्रोफेसर सीपी गुप्ता इतने बिजी और इतने ये हैं कि जल्दी एक्सेप्ट नहीं करते हैं।
इनकी बुक्स भी है क्या सर? सीपी गुप्ता मुझे लगता है बुक्स भी है क्या सर की?
बुक्स भी है ना।
फाइनेंस
तो
के हैं।
ये रिटायर्ड हैं और कई जगह आईएम और कहाँ के ये एजेंट और पता नहीं क्या क्या फैकल्टी हैं। तो मैंने उस दिन फोन किया तो बोला कि सिन्हा जी आप 6 तारीख को छोड़ देना, 6 को मेरा फैमिली फंक्शन है। तो हमने कहा लास्ट में कर देता हूँ 7-8। कल क्वेश्चन
सर इतने सीनियर फैकल्टी 2 दिन दे रही है, बहुत बड़ी बात है।
हाँ नहीं, कल क्वेश्चन पर सुनती प्रोफेसर बीके सिंह का, इतने फैंटास्टिक।
कल मैंने अपने स्टूडेंट को बोला था सर, जो भी कर रही है ना मेरे अंडर, निकिता है सर, निकिता दहिया, आपने देखा होगा, आ रही है निकिता, वो मेरे अंडर ही पीएचडी कर रही है। तो उसको मैंने कहा था सारे पॉइंट्स अच्छे से नोट करके करना है। लड्डू इधर आओ। तो उसको मैंने बोला था सर, तो वो कर रही है। 2 बच्चों ने भी थीसिस सबमिट करी थी, मैंने आपसे उस दिन पैनल का नाम लिया था। बट वही है सर, आजकल ना बस एक ना बच्चों को ये डिग्री का ही हो रहा है, मतलब डिग्री
क्रेज ही खत्म है। आप
हम जैसे टीचिंग में इसलिए आए थे ना कि क्रेज था। फोर उठाओ एक बार, मामा का है। हमें जैसे ये था ना कि सर कुछ सीखे, क्योंकि मैं तो टीचिंग में छोड़ के सर 1 साल का मैंने गैप लिया था सिर्फ पीएचडी समझने के लिए। हालांकि इतना बहुत कुछ है समझने के लिए।
अब ये है ना कि जो तुम्हारे जैसे स्टूडेंट था, उससे पहले ज्योति रानी थी, उसके बाद धीरे धीरे डिटोरिएशन होता जा रहा है। और आज
बच्चे ना सर बस डिग्री के लिए, कागज के लिए लग रहा है कर रहे हैं। मतलब सर आपको आजकल पता है सॉफ्टवेयर भी है, एआई टूल्स इतने अच्छे आ गए हैं और अच्छे भी हैं नो डाउट, लेकिन वो सीखने की वो नहीं है, बुक्स तो उठाते ही नहीं है। हम कितना बोले बुक्स नहीं पढ़नी है।
तुमको सीपी कविता बोले नहीं कि थीसिस लिखना है तो सॉफ्टवेयर बता दूंगा तुझको।
बच्चे पूछते हैं सर, हम इंटरप्रिटेशन लिख चुके।
नहीं, आप ये बताओ ना कि बच्चे बना तो लेंगे, पीएचडी भी हो जाएगा, लेकिन कभी टीचिंग में जाएंगे तो क्या बताएंगे बच्चों को?
नहीं बता पाएंगे सर, नहीं बता पाते।
बहुत बुरी स्थिति है एकेडमिक्स।
सर हमारा बहुत डाउन जा रहा है। मतलब मैं यूनिवर्सिटी में एसआरएम में पढ़ा रही हूँ, बहुत बड़ी यूनिवर्सिटी है, बच्चे बहुत बढ़ रहे हैं, बट एक्चुअल में वहाँ जो रियलिटी है हमें पता है। मतलब सिलेबस वही घिसा पिटा, जिसका एप्लीकेशंस नहीं है, कॉर्पोरेट में कोई काम नहीं आना, प्रैक्टिकल लाइफ में कोई काम नहीं आना। जो हमारी केस स्टडीज भी हम लोग करते थे असाइनमेंट, वो सिर्फ कागजों में रह गए सर, कुछ नहीं रह रहा कुछ सीखने का। फिर उनको देख के सर हम, हालांकि बड़ी 80 बच्चे बैठते हैं सर मेरी क्लास में कॉस्ट एंड मैनेजमेंट अकाउंटिंग में, बट मैं थोड़ा सा टाइट हूँ सर, मैं थोड़ा सा रहती हूँ स्ट्रिक्ट अटेंडेंस को लेके और स्टडीज को भी लेके। तो मेरी क्लास में तो सीरियस है, क्योंकि अकाउंट्स की भी क्लास है, आप इंगेज हो जाते हो, प्रैक्टिकल्स कर रहे हो। बट थ्योरी क्लास में और जो आजकल क्या होता है यूनिवर्सिटी में, ऐसा नई टीचरें रखते हैं, जो नई टीचर्स हैं उनको कंट्रोल करना, और एज डिफरेंस कम होता है ना सर, एक एज डिफरेंस भी लगा लो, और नईयों को सीखने में बहुत बच्चे टेकिंग फॉर ग्रांटेड लेते हैं, अटेंडेंस ले जाते हैं, कंट्रोल नहीं होते। सीनियर टीचर्स को ये रोकते नहीं, सैलरी बढ़ानी पड़ेगी, इश्यूज हैं जो भी है, अभी सीनियर फैकल्टी को तो आपको देना पड़ेगा ना। तो बस यही क्लेश चल रहा है सर। बट मैं यूं खुश हूँ सर, एलडी को मैं आ गई हूँ, 15 मिनट का डिस्टेंस है, बच्चे को टाइम दे सकती हूँ सर, अपने आप को टाइम दे पाती हूँ, मेरे लिए वो
ठीक है, बढ़िया है,
बेस्ट है सर मेरे लिए। तो
मोर और लेस ये मान के चलो कि सब जगह यही हाल है, नॉट इवन के डीयू के कॉलेज का भी यही हाल है। ऐसे गंदे टीचर भरे हैं नहीं लोग कि उसकी स्थिति ऐसे ही है। बस ये है कि अब बस ऐसे ही चल रहा है। हम लोग तो इससे मुक्त पा गए, लेकिन कभी कभी देख के मुझे लगता है ना, मैं अभी चौधरी बंसीलाल जा रहा हूँ,
हाँ जी बता रहे थे,
वहाँ भी देखता हूँ ना, तो मैं कहा कि इसके वाइस चांसलर 2 टर्म रहे प्रोफेसर आर के मित्तल, और मैनेजमेंट के प्रोफेसर थे, और मैनेजमेंट की इतनी दुर्दशा है वहाँ, हमने कहा परमात्मा ही संभालेगा इस सबको।
मैनेजमेंट कोर्स को तो हरियाणा में जैसे बिल्कुल 0 कर दिया इन्होंने एमकॉम से भी नीचे कर दिया उसको, बल्कि
एमकॉम से नीचे। चौधरी रणवीर सिंह में एमबीए के बच्चों से ज्यादा सीरियस एमकॉम का बच्चा है।
सच है सर, मैं बीकॉम के स्टूडेंट्स को पढ़ाती हूँ, वो सीरियस है, बीबी वाले नहीं है। एडमिशंस बीबीए में ज्यादा है, 1 मिनट पारू, 140 स्टूडेंट्स हैं बीबीए में सर, 160, 2 सेक्शन में 160। आप सोचो एक क्लास में 80 बच्चे बिठा के पढ़ा रहे हैं। बीकॉम में है 57, बट वो सीरियस है, उनकी फीस भी कम है, वो पढ़ते भी हैं, और सेम ही सिलेबस, ज्यादा फर्क ही नहीं है, सिलेबस में रख रखा है,
सिलेबस में कोई फर्क नहीं,
कुछ भी नहीं। तो फिर तुम 1-2 डिग्रियां चला क्यों रहे हो? और टीचर भी सर निकम्मे है, मैं बताऊं, टीचर खुद बच्चों को भगा देते हैं, मास बंक करा रहे हैं, भाग जाओ, लास्ट में 2:30 बजे के बाद तो क्लास ही नहीं लेते। एक मेरी क्लास है, 1-2 टीचर्स के हैं जिससे डरते हैं कि नहीं जाएंगे, कि मैडम तो रगड़ देगी। बाकी मतलब मेरे को तो ये होता है ना, माँ बाप ने पैसे दिए हैं, भी हार्ड मनी होती है, कमा के दे रहे हैं, तो अक्षर बैठ के लिख लो, पढ़ लो। लिखने का तो रोने लग जाते हैं लिखवाते हैं, तो उनको चाहिए पीपीटी बना लो, दे दो और नोट्स बन जाए।
बस यही है, बहुत बुरा स्थिति है,
बहुत ज्यादा। एजुकेशन तो सर बहुत खराब है,
अंतिम झेल रहा है।
आप सही टाइम पे निकल गए सर, हमें तो आगे 5 साल बाद ये लग रहा है पता नहीं क्या होने वाला है। टीचर्स की रिस्पेक्ट भी नहीं रही सर उतनी।
अब देखो ये प्लेटफॉर्म मैंने क्यों एक्सेप्ट किया या सेलेक्ट किया, मेरा ये है कि चलो मेरा कोई इससे कुछ लेना देना नहीं है। मेरा ये है कि भाई जितने भी रिसोर्स पर्सन आते हैं इतना उसमें सोर्स हो जाए जिससे उनको हम एक कंफर्टेबल पेमेंट कर दें। हम फ्री तो पढ़ाएंगे नहीं, तो बस इतना ही चाहिए। और मेरा एक कम ही बच्चा हो, सिंसियर बच्चा हो। और जो भी रिसोर्स पर्सन हमने इसमें रखा है ना, शैलेश सिंह भी पीएलएस और एससीएम पर ठीक बताया, क्वेश्चनियर पर बताया, ये भी सीनियर प्रोफेसर हैं। तो मैं इस सोच के रखा कि चलो जो 10 ही बच्चा सीख लेगा ना तो एटलीस्ट सीख लेगा। ये प्लेटफॉर्म का काम ही यही है। मुझे कोई इससे पैसा थोड़ी कमाना है कि कोई पैसा दे जाएगा।
नहीं सर, इसके पीछे तो मैडम की इंटेंशन ही बहुत प्योर है।
हाँ, तो ये मेरा है कि भाई चलो एक तो चलता रहेगा और कुछ बच्चे सीखते रहेंगे और बच्चे को छोटा मोटा काम कराते रहेंगे। अब मैंने सोचा ना कि अब मैं 6 डे वर्कशॉप नहीं कराऊंगा इस पर, ये थोड़ा लंबा होता है। अब इसको कराऊंगा एक टेक्निक्स पर 2 दिन का, इसलिए कि थोड़ा बोरिंग भी कभी कभी हो जाता है कि 6 दिन आप चल रहे हैं। तो कुछ एक्सप्लोर कर रहे हैं इस पर भी। चलो ठीक है,
ओके, नमस्कार सर। चलो बाय करो सर को।
बाय
बाय।
चलो
मम्मा, मैंने
ठीक है सर, थैंक यू।